I thought I'd have a go with this Leibniz thing again. So I've got all this to set up basically. So I've got his weights, his stops. I've previously used this spring. I'm going to have a go with this one now, slightly different spring. Just a bit tougher, so less of a difference basically in weight problems. I've got his weights, 4 of them, and a spring that's just rolled off. I have to get them weighed, so we'll have to delve in the bag for the scales. 15 minutes later, yeah, we found them, so we've got a scale, so we'll get them out and get this shit weighed. Don't know if it's relevant, but we can weigh the spring, but it's hard to get it to stand up. What a pain in the arse. Oh, come on. I like that. Fuck off. I'll be back. Right, we're back. Improvisation at its best. So I got 12.17 grams. Yeah, 12.17. Right, so we've got the 4 weights there. That's 97.98. Alright, yep. Try that again. Yeah, 97.98 grams. So see how much one of those weighs. So if we divide 97.98 by 4, we've got 24.495, so we'll see what this weighs. Oh, it's not even turned on, is it? Bollock. So this is the one that will be used as the one when it's dropped, so with the marker on, and that's 24.70. 24.70. So 24 point. So it's a little bit over in weight, 0.2 of a gram. Alright, so next we've got to get these things bolted together. Yeah, so there we go. Bolted up. Now it's all bolted up, we'll give it the ting test. Oh yeah, that sounds pretty good. Right, I'm just using a different spring, slightly stiffer. That's cut to the height of the spring. The edge along there. I'll show you measurements in a bit when I find my tape measure. But for now, we can trust that it is the same height as the spring. And it weighs. That's how tired I am. It measures 10 centimetres. So the point of this basically is it's the same sort of height as the springs. So when put weights on, you know, if it gets trapped, you know, the weights are compressing the spring. It's a quick way of measuring it, really. So with the one mass on, and put that there, and it just falls over. So the weight of this isn't enough to, you know, it's not. Yeah. Now with the 4 masses on, that basically pushes it back up a little bit. I don't know if you can see. So yeah, basically it pushes it, yeah, up. So obviously this, I was hoping this wouldn't compress at all under that weight, so we just could get a equal measure, make it easier, but obviously it does compress, so say about 1 mil. So yeah, it's a real shame on that one, because I was hoping, I'll say no compression, and obviously we'd get equal measures, but we're still going to have to factor in that the four together do compress it a little bit, so obviously it's a little bit of an advantage for the slower one. So we're going to the trouble of cutting that, so 42 and 10.5, so that'll be his markers for his heights. So here we go. Yeah, so roughly 42. Yeah, roughly 10.5. And that's the spring one, that's as important really. So we've got his doobry there, which is basically just when we put that on there and we set it in some position in the backdrop of this when it's dropping, and we get the camera set up and the tripod lighting and everything, and it's all in a fixed position, so as the weights come down, it'll look the same. If the compression's the same, it'll look the same. It can't look anything different, obviously. It's fucking same. So when the weights are dropped, obviously we've got that set at that stop, and all I do is pull it up against the stop, so I'm continually pulling it up and then just twist it. Simple as that. So basically what's happening is this will be placed in the background, taped down, it'll be taped in a bit, and this is coming down, and obviously it's falling down past it so we can see the measurement basically. But obviously when it comes down, it can boom, it can hit the top of that, so there is a bit of trial and error involved in getting nice clean drops, so we see it. And obviously, yes, there is a bit of editing involved, because you don't want to see a load of all bouncing around, because that's a failed measurement. There's no point showing it. So again now, with that marker basically, that's to the spring, that's to the weight, 4 times the height, and 1/4 the mass, and basically we're pretty much at the top. Simple enough to follow really, just obviously putting different masses on at different heights and just dropping them. Obviously all this will be fixed, the camera will be set up, lighting will be set up, and then just drop them and film them. But like I say, there will be trial and error, boom and so on. So yeah, takes a bit of setting up and getting right, and then obviously getting nice clean drops. I'm going to tape it on somewhere around here, so just checking for levels. Oh, coffee break and a chocky bicky. So still got a bit of coffee left. Well, that accompanies a clean, doesn't it? You get distemper or something from that. Anyway, next job, get this taped and the tripod set up, the phone mount on the tripod, all that bollocks. I suppose at some point I should point out what I'm actually doing here. So basically we'll be dropping a 1 mass and then a 4 mass. 4 mass at one distance and a 1/4 of that mass at 4 times the height, so it'll be going twice the speed. But I think the important thing to note is it's going twice the speed, but it is 1/4 fourth. You could say 4 to 1, or you could say 1 to 1/4, however you want to look at it, but the important part to take from it is actually a quarter, or 1 to 4 ratio. There we go. Not pretty by any means, but it ain't going anywhere. So we've got to get this part taped down. But obviously don't want to get it too close, because if you have it like ridiculously close, you know, the chances of getting it to drop past without it twatting it. We're setting it a bit further back, which you could maybe argue that the perspective, you know, if it turns this or this or whatever, but we're still looking for those straight drops. And from the perspective of the camera, when it comes down, you know, if it's fixed in the same position, it's going to give the correct readings. So pretty simple, but you know, takes a bit of time. Right, got the debris taped in. Might have to adjust it, so we'll have to see when start dropping if it starts twatting this all the time. We'll have a go. Yeah, I suppose I should point out that the reason for taping everything down is so that's in a fixed position, and when the camera's set up, when the tripod's set up and the camera's up and the lighting's up, that everything's fixed. So when the video's taken, it's all taken from the same perspective, and therefore it's a good measure. So goes tripod, we'll get that set up and get us lighting on. So with the tripod, we'll basically wedge it in with the chair so it's nice and solid, so again in a fixed position. There we go, lighting on. So I'm just got to raise this up now and get the phone holder on. I love this thing, makes me feel like a real TikToker. I'm going to get this debris bolted on now. It's great, you get a little Allen key with it that fits the bolts, which is pretty useful. And then we'll be bolting it onto that, yeah. Is that the thicker one or the thinner one? Somewhere on there anyway. Yeah, that's the thicker one, so that's the thinner one. So I have to piss about getting those in the right position so there's enough lighting. In a bit. Oh man, I had a right dilemma then. Just gone for fit this thing, and obviously just showing you the Allen key, and I put my phone down and I was like, could I fuck find there? It had only gone and got stuck to the magnet thing on my case. 20 minutes been looking for that. Fucking hell. There we go. We've got that little debris bolted on. I can twist it and obviously adjust the spacing to get the camera in there. Right, had to hunt for a plug for the USB on the lighting, so I'll get that hooked up and just hope that doesn't go up in flames. Let's give it a go. Well, the blue light's come on, so I take it that's good. Hey, there we go. On, off. Amazing. I'm just more than on and off. So you got on, off, and then you can change the. Oh, you see that? I think you can. You can change the brightness anyway. You can turn it down. Ah, there we go. Turn it down and up, and then I think there's a colour change as well. Like can't really see that. Turn it up. I think there's like different. That's like a bluey light, I think. Yellowy light and a white light. Right, so we're all nearly set up now. Just got to get the camera in place to point out main reason for taping down as well, obviously, is when I swap these out, the weights and the heights, that everything's kept in the same position, nothing's altered. So when it's filmed from the fixed point, it's all the same. Basically, phone in place now, I'll have to spend some time basically getting that set up, so, and obviously fixed. So we're in focus, and obviously we can see everything. So when setting it up, obviously, as this drops in, it automatically triggers. So I have to film a bit of the height above, rather, you know, because we're only interested in the bit that obviously I can't see because the others are. But we're only interested in looking at the compression, and obviously I need to give it a bit of height, so as it comes in, it triggers before the whole thing's over and done. So, you know, we want to see what's going on. Right, just done a few tests on whether it triggers it, and it seems to, so I think we'll just go for it. Just like to point out here that what the compressions actually are, you know, when this test is done and filmed, can't be seen. So I'm going to set the height for the full mass, and yes, they are just taped together. As you can see, they're very free to fall. The correct diameter for this tube. There's no sort of chafing on the way down. So I'll set the height for that one. So there we go. Full mass set up. So from the bottom of the mass to the top of the spring, that's the distance it'll be dropping. Like so. So I won't be releasing them by the method I've just shown. That was just to show the distance was correct, but basically I'll be looking down, trying to drop it so it doesn't twat onto that all the time and get good clean drops. So holding it from above, pulling it up against stop, and then just letting go. You can't really get much more, you know, quick release than that. So in all honesty, probably have to do this about 20 or 30 times. You know, could get lucky and get a good drop on the first one, you know, the third one, but basically just do a good amount just to, you know, get the best results basically. Right, I've done a series of drops now. I can't review it because I can't move anything, so I'll swap out, but basically you're just dropping that like that. It activates the slow-mo, records it, and there we go. I'm now going to swap out for the one mass at the full heights without knocking anything, without knocking the camera or the lighting, or so everything's in the same position. So we'll have a go at that. So we've now got as one mass up there, and as 42 centimetre spacing to the top of the spring to the bottom of the mass. So we're now dropping the the one mass. Again, pulling it up to the top and just letting it go. You can't get much more quick release than that. Right, I've done about 10 of these now. I'm going to do probably a few more, yeah. Obviously, like I say, can't see the compressions, but from what we saw earlier, it should be roughly about a mil between them, proving kinetic energy and Leibniz, because this is basically Leibniz 1 versus 4. You know, is a one mass from 4 heights the same as one mass from 4 heights? Sorry, that's how tired I am. A one mass at 4 heights and a 4 mass at 1 height are the same impact energy, but I say the 4 mass has got that little bit of advantage with the weight compression on the spring, but this should be a little bit closer than the previous one. Oh god, it gets quite tedious, this does. Fucking hot as well with that light there. Do a few more, and then what I'll have to do is, I can't review the footage while it's in there, so take it out, check it. If it's favourable, we'll be packing away. If it's not, then I'll have to adjust and try again. Right, I'm going to call it a day at that and just check what footage I've got now. Right, after reviewing the footage, the one mass at 4 heights got a couple of good clean drops on there, not many, because it's harder to film those ones and get it right. The 4 mass at 1 velocity got quite a few good ones, so it's pack away time. Before I pack away, I just like to show that basically the height at which the 1 mass has dropped from, there's a piddly little bit there, which obviously if I wanted to make it go faster, yeah, barely. But anyway, I'm hoping from the footage, the frame rates should be able to, if we take 2 reference points for both masses dropping, we should be able to determine the velocity of 1:2 ratio as well. So there we go. That's basically it. Should pack away now. The joy. Right, so we're all tidied up now. So we'll just go through simply, round it everything up. So just say it's 100 grams, going 1 velocity. 100 times 1 velocity is 100, so that's the momentum. In the case of the 25 gram mass, going 2 velocity, 25 times 2 is 50, so this is half the momentum of this one. But at the end of the day, momentum doesn't compress springs, newtons do. And in terms of energy, we've got half the mass of the 100, so that'll be 50. We've got 1 velocity, 1 squared is 1. So as energy will be 50 times 1, and that's 50 energy. In the case of the 25 gram mass, half the mass, 12.5. It's going 2 velocities, so 2 squared is 4. 12.5 times 4 equals 50. So in terms of energy, or the amount of force it's going to collect to compress a spring, these should be equal compressions according to momentum. Obviously this one should compress a spring twice as much, or however you want to say it, but they are equal in terms of energy. So that's it really, we're all done. I will upload the footage separately because it's in a different aspect ratio, because I have to film it the other way to allow it to drop in. So I'll have to review that, edit it, get rid of the ones that are bad runs, bad drops, and see what we get. If anybody's continued to watch up to this point, thanks for watching. I've gone through obviously a lot of the setup just to show what's been done, showing all the measurements, that everything's how it should be, all the weights are how they should be, all the measurements are how they should be, and then obviously the results will come separately, and that's about it really. I mean, I can't physically show anymore. All I can do is do the experiment, show the results. They're all in line with kinetic energy and MGH. The reason obviously a Leibniz proposal was accepted is because it's true. When it's tested, it's physically true. Clearly the momentums are not the same, so there's obviously another explanation going on, which is why Leibniz was accepted. The reason I've basically shown all the setup and how it's done is so if anybody wants to replicate it, which would be cool actually, because obviously it'd do the same thing, so it'd be interesting for more people to do it. Obviously this experiment doesn't seem to be on YouTube anywhere. I have searched for it and it's you know, it's difficult to find. I'm sure it's done in, you know, colleges and universities all over the world, but you just don't seem to find it. So, you know, a better version that I've now done hopefully might help some people to understand what, you know, really happens.